Good morning, all of you. Myself, Dr. Sudharani from SR University. Today, I am going to discuss about the topic data science in cloud computing, which is very important thing to discuss. What are the present benefits and what are the present challenges and what are the present trends in cloud computing. Majorly, there are the three major cloud service models. These three cloud service models can be maintained by any cloud service. The three major cloud services are IaaS, PaaS, SaaS. Infrastructure as a service, platform as a service, and software as a service. These are the three major cloud services where the cloud service providers are providing for the customers, and the customers also mainly depend on the cloud for these three cloud services. First one, infrastructure as a service. It provides with the capability to provision processing, storage, networks, and other computing resources. So infrastructure as a service is the main criteria where the clients used to be depend upon the cloud. Whereas infrastructure as a service is the environment where we cannot afford or where we cannot get the infrastructure to run an application. For that, we are depending on the cloud for the infrastructure, whatever we want to develop. And a cloud is ready-made, it is having the ready-made infrastructure, and it can, and the according to the client services also, according to the client requirements, it can be customized. The infrastructure can be customized and it can be useful for any kind of the clients easily. So the first mode, the first service of the cloud computing, first useful service of the cloud computing is infrastructure as a service, IaaS, where we can share the networking, where we can share the infrastructure to run any kind of the application on the cloud platform. It allows the consumer to develop and run arbitrary software, including operating systems and applications. And this is very important point, like irrelevant to the operating system, the cloud platform, it will maintain any kind of the operating system where we can easily shift from one operating system to another operating system without changing any kind of the settings of the platform. And the consumers does not manage or control the underlying cloud infrastructure. So when we are using one kind of operating system, or when we are running any kind of application, it doesn't need to manage or to control any kind of the infrastructure. Means it is very flexible to one customer to another customer. No need to change any changes for the requirements of the customers. No need to change the inbuilt settings. And it is very feasible. It can be very customized according to the requirements of the client. The consumer has control over operating system, storage, and deployed application. And one more good thing is we cannot depend upon the admin to give any permissions, to give any access permissions to run the applications. A client or a consumer can have the entire controlling overall the operating system, storages, and the deployed applications. There is no restrictions. The consumer may have limited control of select networking component, example host firewalls. So coming up to the security policies, the consumer is having limited control of selected networking components. And the commonly used IaaS applications in real time where we are using this IaaS application service models. First one, Amazon Web Service, AWS, it provides the IaaS service models in Amazon EC2, that is Elastic Compute Cloud, where we defaultly using in our AWS platform to run any kind of the application. Amazon S3, Simple Storage Service. This is EC2 and the S3 both are the object-oriented storage, especially using in the AWS platforms. And next is Amazon EBS, Elastic Block Storage, Amazon VPC, Virtual Private Cloud, AWS Direct Connect. These are some of the IaaS applications provided by the Amazon Web Service providers. And IaaS real-time examples. We can also see the real-time examples like high traffic e-commerce flash sale, like Flipkart's Big Billion Days or Amazon Prime Day in India. So here, Amazon EC2, it compute power. The purpose is host the core websites, backend logic, and API gateways. Amazon VPC, Virtual Private Cloud, it's networking, and the purpose is to provide secured networking. Next, Amazon S3, Simple Storage Service. It's static asset storage. Purpose is scalable object storage. Amazon DynamoDB, and it is NoSQL database, and the purpose is real-time, low-latency data access. And the real-time data flow, users hit the website routed via internet gateway to EC2 web service. EC2 services retrieve static content from S3, where web servers communicate with DynamoDB to fetch product information, cart, etc. Backend APIs and application logic run on EC2 in private subnets. This is the architecture of infrastructure as a service with real-time example. You can see these are the users, and this is Amazon, and this is VPC, Virtual Private Cloud. And in the VPC, we can see Amazon EC2. EC2 is where the object storage type. S3 is also object storage type. Amazon DynamoDB is the NoSQL database. And this VPC, which is called as AWS Cloud, this is connected to the networking, compute, database, and storage. So Virtual Private Cloud is connected to the networking by using the Amazon EC2 and Amazon S3, which are the object-oriented storage systems in the AWS Cloud architecture. And next service is the PWS, Platform as a Service. So first we see in the IaaS infrastructure as a service, and now it is the platform as a service. So it has the capacity, platform as a service has the capability to deploy onto the cloud infrastructure. Consumers can create applications using programming languages, libraries, services, and tools supported by the providers. So unlike the infrastructure as a service, platform as a service, it has a capability to deploy onto the cloud infrastructure. See, first by using the IaaS service, a consumer can take the infrastructure into his control. After that, by using the PWS, platform as a service, he can deploy whatever the applications he wants. He can deploy onto the cloud infrastructure. Deploying is called as a platform as a service, and adopting the architecture is called as the infrastructure as a service. Consumers can create applications using programming languages, libraries, service, and tools supported by the providers. And here the consumers is having customized tools where he can create his own applications by using different programming languages, libraries, and the services. Everything is very flexible and customized for the consumers. The consumer does not manage or control the underlying cloud infrastructure, including network, servers, operating systems, or the storage. And this is a good point for the clients who are adopting or who are depending on the cloud services. So once they are connected to the cloud, once they are adopted the infrastructure and deploying any applications, they can get entire control over including the networking, servers, operating system, and the storage. There is no limited, there is no barriers, or there is no access permissions from the admin to wait. So the customers are having entire accessibility over all the networking. The consumers have control over the deployed applications and possibly configuration settings for the application hosting environment. And the commonly used PaaS application, Amazon Web Services, AWS, that is Elastic Beanstalk. In the previous class, we seen the practical on Elastic Beanstalk. And Google App Engine, GAE, Microsoft Azure App Service, Heroku, OpenShift, that is also called as Red Hat, Cloud Foundry. So these are the commonly used PaaS applications by the AWS service providers. Next service is PSW. Next service is SWS, Software as a Service. Software as a Service. The consumer is used to use the provider's applications running on a cloud infrastructure. The applications are accessible from various client devices through either thin client interface such as a web browser. The consumer does not manage or control the underlying cloud infrastructure, including network, servers, operating systems, and storage. Commonly used SWS applications, customers relation management, CRMs, enterprise resource planning, ERP, email marketing software, accounting software, human resource software, security softwares, collaboration tools, document editing service, communication softwares, and contact center softwares. And this is the simple service models with the different services. You can see here traditional on-premises, here AWS, infrastructure as a service, containers as a service, platform as a service, function as a service, software as a service. So here we are having so many different services. And see here, first, traditional on-premise, function, infrastructure as a service. It is also provide the function, customer container as a service function, platform as a service function, function as a service function, software as a service is also a function. So this is here managed by the function blue boxes are indicate managed by the consumers, and gray boxes are indicates managed by the cloud providers. So here with the different services, the function is everything is managed by the consumer itself. So in IWS, CWS, PWS, FWS, everything, all the functions are controlled or managed by the consumer itself. Only in software as a service, the function is managed by the cloud providers. Coming to the next application part, in traditional on-premise, IWS, CWS, PWS, the application part is again managed or controlled by the consumer. Whereas in FWS and the SWS, the application part is maintained by the cloud providers. Next, runtime and container. In traditional on-premise, the runtime and containers are also managed by the consumers. IWS, CWS. In running runtime and container, IWS and CWS both are managed by the customer or consumer itself. Whereas PWS, FWS, and SWS, these three are managed by the consumers. Coming to the part of operating system, in the traditional online premise, the operating system, and in IWS service, the operating system, these both are managed by the consumer. Whereas in CWS, container as a service, platform as a service, function as a service, software as a service, in these three services, in the four services, the operating system is purely managed by the cloud providers. You can clearly see the differences between this table is very nice, but to understand clearly all the services and with all the characteristics in one place. Virtualization, traditional on-premise, only in traditional premise, virtualization is controlled by the client or the consumer. Whereas in all the services like IWS, CWS, PWS, FWS, and SWS, in all the services, the virtualization is maintained by the cloud providers. Same like physical server also, only in traditional on-premise, the physical servers is maintained by the consumer. Whereas the remaining all the services, IWS, CWS, PWS, FWS, and SWS, all the services, the physical server is purely maintained by the cloud providers. And network storage, same. The network storage is also only in traditional on-premise. The network and storage is maintained by the client or the consumer. Whereas the network and storage in the remaining services are purely maintained by the cloud providers. Same like data center. Data center is also only in traditional on-premise. The data center is maintained by the consumer. Whereas remaining all the services are maintained by the purely cloud providers. So this is the best table to understand all together once, where we can see the differences between the services as well as the functionalities of the AWS cloud providers. Fine. This is very interesting topic, and as per my interest, this is very interesting topic, as well as this is a very useful topic where we can see the AWS pricing models. So we are having three fundamental drivers of cost with AWS. And that is, first one is compute, storage, as well as the data transfer. Compute, storage, and data transfers. These are the three different types of cost drivers in AWS. Maximum, so many people don't know what are the cost model which they are using for the cloud, what they are depending. This question, maximum people don't know what are the cost pattern they are following. But if you observe, so here any customer or any consumers, from the normal person, individual person, to the multinational CEO or the owner of the companies, whoever the person may be, the persons or the consumers of the cloud has to be fall under these three categories. That is compute, storage, as well as the data transfer. These are the three types of cost which we are paying for the cloud service. And first one is the compute. Compute means charge per hour or per second. So where if you want to use only the infrastructure as a service, so where to run the application, we are hiring and we are using the cloud. So that called as what? Compute. Means we are hiring the architecture of the cloud only for some specific time. So that specific time is called other specific time, maybe 1 hour, 2 hours, or 3 hours. So we are paying only for that specific time. So that is called as a compute, where we are paying for only per hour or per second. So, and this compute cost service, it may be varies by instance type. It may be varies by instance type. So what kind of the instance we are using, depending on that, the cost may be varies from one service to another service. And the next one is storage. Storage means, see, now whatever the practical we are seeing in my past lectures, everything comes under compute only. Means we are using the environment of the cloud, and according to the time, we are paying dollars for the cloud services. That comes under the compute. But we are having one more type of the cost, that is storage, where we are using cloud service only for the storage purpose. So we are not in that type of the cost. We are not using any infrastructure of the cloud. Only we are using the cloud only for the storage purpose. The best example for the storage is your Google Photos, where unknowingly every customer of the smart mobiles are using the cloud storage. So that comes under storage type. So this storage charges typically per GB. So it comes under the storage. So up to what GB of data we are storing. So up to that storage only we are paying. That is basically charged typically per GB. So this is the storage type of cost. And next we are having the data transfer. So one more type of the cost type is data transfer, where in the data transfer we are not using the infrastructure of the cloud, or we are not storing anything onto the cloud. So simply here we are uploading and downloading the data to the cloud or from the cloud. So uploading and downloading data from the cloud or to the cloud is called as the data transfer. Here the terminology we use for the uploading and downloading is outbound as well as inbound. So the data transfer is having two methods, that is outbound and the inbound. So for the outbound, outbound is aggregated and charged. Outbound is aggregated and charged. Inbound has no charges with some exceptions. So outbound we are having, means if you want to give any data to the cloud, so it is aggregate and charged. Inbound doesn't have any charge. And this data transfer is charged typically per GB. Like storage only, here the charges is also depends on the typically per GB, how much of GB you are using. So according to that, you have to pay the money for GB, either only for the outbounding, not for the inbound. This is the AWS pricing models. So three types of pricing models are there: compute, storage, and data transfer. How do you pay for AWS? So here, pay for what you use, pay less when you reserve, pay less when you use more, and as AWS grows. So how do we pay? So always we have to pay only for what we use, not for what it is available, how much it is available. We are only paying for what we are using from the entire environment, what we are using. That is pay for what you use and pay less when you reserve. And if you are reserving something and you are using it later, for that you have to pay very less, like your Google Photos. So in the Google Photos, you are reserving your cloud and you are using later. So pay less when you reserve. Pay less when you use more and as AWS grows. So if you are continuously using the cloud, even you become the customer of the cloud. So always when you are using more, so always you give the less price. So cloud will gives you discounts when you are the regular customer. Cloud will gives you a discount when you are using much. When you are using much, you can pay very less. See here, pay for what you use. Pay only for the service that you consume with no large upfront expenses. See here this is 1 by 2, this is 1, this is 0. See, this is 1 by 2, this is 1, this is 0. So whatever you are using, you have to pay only for that service, not for entire service. Pay less when you use. So see EC2 instance, on-demand, Muri, Puri, RE. The reserved instances are available. Reserved instances are available in 3 options. All upfront reserved instance or ORI. All upfront reserved instances, Puri, partial upfront reserved instances, Nuri, no upfront payments reserved instances. So these are the different 3 options where to give reserved instance. So on demand, Nuri, no upfront payments reserved instances, Puri, partial upfront reserved instances, Ori, all upfront reserved instances. Pay less by using more. Realize volume-based discounts. Pay less by using more. You can see here. So you are using more. So you are paying very less. Because you are becoming the regular customer for the cloud. So they are giving you some discounts. Realize volume-based discounts, savings as usage increases. When you are using more, so you can pay very less. Type pricing for the service like Amazon Simple Storage Service, Amazon Elastic Block Store, Amazon Elastic File System. The more you use, the less you pay per GB. Multiple storage services deliver low storage cost based on need. Pay less as AWS grows. Pay less as AWS grows. AWS focuses on lowering cost of doing business. This practice results in AWS passing savings from economics of scale to you. Since 2006, AWS has lowered pricing 75 times. Further higher performing resources replace current resources for no extra charges. Custom pricing meet varying needs through custom pricing, available for high volume projects with unique requirements. Service with no charges, service with no charge. Amazon VPC, Elastic Beanstalk, auto scaling, AWS Cloud Formation, AWS Identity and Access Management, AWS Foundational Service. AWS Foundational Service. So we can see here AWS Foundational Service, applications, virtual desktop, collaboration and sharing, platform service, databases, relational, NoSQL, caching, analytics, cluster computing, real-time data warehouse and data flow work. Application services, queuing, orchestration, app streaming, transcoding, email search, deployment management, containers, DevOps tools, resource templates, usage tracking, monitoring and logs, mobile services, identities, synchronous mobile analytics, notifications. Foundation service, compute, virtual automatic scaling and load balancing. Networking, storage is object, block and archive. So AWS categories of services, here we are having the very different AWS categories of service like analytics, application integration, AR and VR, blockchain, business application, compute, cost management, customer engagement, database, developer tools, end users computing, game tech, Internet of Things, machine learning, management and governance, media services, migrations and transfers, mobiles, networking and content delivery, robotics, satellites, secure identity and compliance, storage. These are the different categories of AWS services. And cloud computing, AWS categories of cloud computing, we are having the AWS categories of compute services, Amazon EC2, AWS Lambda, AWS Elastic Beanstalk, Amazon EC2, auto scaling, Amazon ECS, Amazon EKS, Amazon ECR, AWS Fargate. Storage services, here we are having Amazon S3, Amazon S3 Glaciers, Amazon EFS, Amazon EBS. Management and governance service, AWS Trusted Advisors, AWS CloudWatch, AWS CloudTrail, AWS Well Architect Tool, AWS Auto Scaling, AWS Command Line Interface, AWS Config, AWS Management Console, AWS Organization. Security Identity Compliance Services, AWS IAM, Amazon Cognito, AWS Shield, AWS Artifact, AWS KMS. So these are the different AWS categories of cloud computing and self-assessment also. So these are some simple explanation regarding the different services of AWS cloud services like IWS, SWS, and PWS. I hope today's class is clear for you, and let us meet in another session with one more topic. Thank you all.